Good afternoon, everyone. Okay, let's wait for 10 minutes and others join and then we'll start our class. Okay, before starting class, I would like to tell something about all of you who is watching this video that on it. This is doubt clearing class. So as far no one asked any questions, means as if people are not all the means all the people are not attending the classes. So if you have any doubt, then you can go to the video sections and you can comment there, means the NPTEL portal. Sorry, hi, good afternoon everyone. Okay, just I want to say something to all of you that if you have any question, then you can ask me in this class, or you can text me with your question to the NTL course section, and we will take care of it and let you know in this class, or in where you send the question. Okay, we will discuss about that. It is better if you have any doubt, then you can ask me this personally, because that's why I'm giving you this facility. We will help with the people. Okay, 6 till 6:10 we will wait, and after that we'll start the class. Let me check in between. Yeah, it's working fine. So till 6:10 we'll wait. Then we will start the class. Let me check once it's recording or not. It's recording. Okay. Okay, 6:10. So let's start the class. I'm sharing my screen. Kindly tell me if my screen is visible and I am audible to all of you. Hmm. I think my let me check once. Okay, my audio is there. Okay, so today date is let's start the class. Okay. So my first question I'm writing it here. And I'm giving you options. So we have to select some option among them. Paramagnetic and diamagnetic. Both diamagnetic. Okay. Okay, let's solve the question. First, we have to know what is the geometry of the complex. So between Cn minus and Cl minus, we know that this is a strong field ligand. And this is a weak field ligand. So it will form the low spin complex, and it will form, it depends on the geometry. Okay, first of all, this question is very much good because okay, this question depends on many things. First we have to know the what is the geometry. Nickel sulfur 2 minus, so there is 4 chloride is attached there, and nickel is here 2 oxidation state. The number of electrons in the outer shell, it will be d8. Okay, d8 electrons. Now I am drawing the d orbital splitting diagram in tetrahedral field. Here I am writing here clearly, if no one is means absent in the class, so that they can also understand. Now I'll fill the electron. So it has 2 unpaired electron. So it is a paramagnetic species. Okay. Now I am moving to the another example. Okay, sorry for the disturbance. For the another example, NiCN4 2 minus, it here nickel is also 2 oxidation state and D8, and here the geometry is square planar. Now we will fill the electrons in a square planar field, means Square planar field means in square planar field how the d orbital splitting happens. Sorry, dxz, dyz. Here is a 8 electrons. Now I will fill the electrons. And you know that sir already discussed all these things. Here the energy gap between these two levels are high. So the electron can't be, mean whenever we will fill the electrons, then we have to take care of these things. Means first we will fill these electrons and we will move to this electron. So what we, this is the diamagnetic species. As there is no unpaired electron. Okay, so what will be the answer? First one will be diamagnetic, second one will be paramagnetic. First one will be the answer. Let me check once if some people having problem in binding or not. Sorry. Now today is the second question. Second question I am writing. We have to calculate. The question is MO bond lengths is 2 whole 6 2 plus. Okay. So how to answer this question? So Mn2. Okay, sorry. Mn is 2 a whole 6. First, when this type of means any type of question in octahedral field or tetrahedral field, when we will see the complexes, we will first draw the d orbital splitter diagram and the electron filling the d5 system. Okay, and it is in octahedral field. Because there you can see the 6 water molecules are getting coordinated, and those are water means it is a weak field ligand. And so how so this complex will be high spin complex. Sir already discussed these things in the class, but as it is a doubt clearing class, so I am solving questions. So please work with me, then it will be better for your understanding. Okay, then now I will draw the d orbital splitted diagram. Means I will fill the orbitals, means E2G EG. Okay, now 5 electrons, 1 2 3 4 5. So here you can see that there is means that discussed during the discussion of Gene-Taylor distortion. If people know, when there is a distribution unsymmetrical distribution of electrons in any of the orbit set to TG or EG, it forms distortion, and bond lengths are not become equal because some elongation or sometimes compression happens. So here we can see that there is no unsymmetrical distribution of electrons in the T2G or EG set. So here we can't see any Gene-Taylor distortion. You can ask me why I am suddenly talking about Gene-Taylor distortion. First, this is a I told this is an octahedral complex. So first we have to think about the geometry. It is an octahedral complex, and we sir already told that in octahedral complexes some distortions happens that leads to the difference in m ligand bond distances, some compression or elongation. So now I am discussing about the gentler distortion. So here we can't see any gentler distortion which can lead to the elongation or compression. Okay, so here all the MO bond lengths are equal. Hello, sorry, someone is telling something or okay. Okay. Now in the third question, if you have any doubt, you can ask me. Now we'll solve the small things. Now next question is we'll calculate some CFSE value, okay, for the cobalt NH3 2 plus complex. So cobalt 2 plus, it is a D7 system. Okay. Now I will show the d orbital splitting. Just consider it is whenever it becomes a degenerate and D2G EG. Now I fill with electrons. Here this NH3 is a weak field ligand. So it is a high spin complex. Now I'll fill the orbitals with electrons. Sorry, means d orbitals with electrons. 7. Okay. Now here it is a 0 level. I already discussed these things. So now CFSE, what will be the value? There are 5 electrons in the T2G level. So 5 into minus 0.4 del O plus 2 into 0.6 del O. It will be minus 0.8 del O. Yeah. So this is the CFSE value of this complex. So first, what the things we have to remember? First, we have to know what is the geometry of the complex. Then we have to know the ligand environment and nature of the complex. These things are important to solve this kind of questions. Now I am moving to the next question. This is a very good question. Okay, I like this question. H2A whole 6 3 plus. The spectrum shows one peak with a hump. We have to answer this question. Okay, so so now titanium 3 D1 system, and now I draw so d orbital split one electron. So here the unsymmetric distribution of electrons in the T2G levels. So it is capable of showing gentle distortion. Okay. So, but what kind of distortion, whether elongation or compression, that we can now I will tell. Let's consider. Okay. Now, if compression happens, now I'll tell you. If compression happens, means you are pushing the z orbitals towards inside, means which are the molecules, which are the ligands are sitting there, there will be much more interaction. So the energy of the d orbital means mm, along the z axis, z compression, no. So means the which orbital having the z component, means the z dx, z dy, z d, z square, their energy will be raised. Okay, dx. Now in case of elongation, it will be opposite, means the z containing component having orbitals will be stabilized. Dxy will be destabilized, dz square will be stabilized, dx square minus y square will be destabilized. Now I have to see the where the if I put the electron, where the energy will be lesser. Okay, so one electron is here, and if I put one electron here, where will be the energy will be lesser. Let's calculate the CFSC. Minus minus 0.0. So here the delta. So this is a negative quantity now. Where the more the negative thing, then it will be the lesser the value. So it will be the higher value than the other one. So it will show the z elongation. If it perform the z out elongation, then the systems will be stabilized. And the so now we can now I am drawing the final thing. Okay, so dx square minus y square, this one dz square, dxz dyz dxy. Okay, one electron is in this orbital. So for if you want to look up for the transition, then electron can be transferred from here to here. So this electron can exist in this orbital also, as these two orbitals are degenerate. So another transition, so when there is no distortion, so only one transition is happening. Let's see here, only here to here, only single transition was happening. Okay, here and now in this case, sorry, in this case, this one transition and this one the another transition, means 1 2. So we are getting two transitions. So there in the question there is a you can see that one peak with a hump. So here we can see that for this one we are getting one peak, and for this one we are getting another peak. So so now it can be easily explained by this concept. Hopefully you people get it. If you have any doubt, please ask me. Okay, let me check once. Okay, now I'm moving to my next question. Sorry. Okay, what is the question number 5? My next question is okay. Gentler distillation shows among these complexes which can able to show the gentler distillation. I am giving the complexes. Now we have to find where the unsymmetrical distribution of sir already discussed these things. For showing gentler distribution, there should be an unsymmetrical distribution of electrons in the this T2G orbital or EG orbital. So here this space is having the D4 electrons, titanium D1, titanium 3 D1, and D7 D sorry D6. Okay, now I'll draw the d orbital split diagrams for all the complexes 1, 2, 3. These all the high spin complexes where the weak field ligands are coordinated with the metal center. So now I am filling 4 electrons. Okay. So among them, which can be able to show gentle distribution, there is unsymmetrical distribution of electron. There is also unsymmetrical distribution of there is also unsymmetrical distribution of electron. This is one question. Another question is where the general distortion will be strong. Here you can see that here the unsymmetrical distribution of electron in the T2G set. Here it will be also T2G. Here it will be T2G. Here it will be EG. Okay. So in EG means dx square minus y square and dz square orbital of where these are the higher in energy, because in that position the interaction is most and it will be higher in energy, means direct interaction is happening. So if the electrons is presenting in the EG orbitals, means that dx square minus y square or dz square orbital, then the general distance will be maximum. So this will be our answer. Okay, these all the questions are from competitive exams. If you solve these questions, hopefully you will get you can solve any kind of questions. or if you don't get, I'm there, you can ask me. Okay, next question is 1 minute. Another question in magnetism. Hopefully now you can solve the question. The complexes, I'm giving two complexes. Now we have to find which one will be diamagnetic and which one will be paramagnetic. Now how we can solve it? Tell anyone can tell. We already solved this kind of question. The first question was my today's class was the similar question, similar type of question. Okay, now tell me what is the oxidation state of nickel here. -6, -2, +4. So these will be the oxidation state of the central metal ion. Now we will these are the octahedral complex. You can see that from the structure you can say that this is a octahedral complexes. Now there are 6 ligands coordinated with the metal center. Now what to do? We have to draw the d orbital splitting diagram. So how in octahedral field d orbital is splitting in T2G and EG set. Okay, let's draw the T2G EG set and nickel 4. Okay, here the specialty of this question. This nickel 4 more the positive charge over the central metal ion, more will be the electrostatic interaction between the ligand and the metal, means between the d orbitals of the these systems. So there is a so here the species will be though flu F minus, I'm writing it here, weak field ligand. I'm writing everything because so that whenever you try to read it, then it will be helpful for you. Weak field ligand, more electrostatic interaction, more will be the d orbital splitting. So del O will be high. Del O high means low spin complex. Okay. Now let's write nickel 4 D6 system. Now I fill 1, 2, 3, 4, 5, 6. So it's diamagnetic. Now in this case, cobalt, if you know little bit, then means you can see that cobalt is O3 always form the means low spin complexes, but here it is not valid. Here the ligand is the weak field ligand. With coordinate, when it is coordinate to water, that is the only exception where it can form the low spin complex, but here it will form the high spin complex. So D6, so it has 4 unpaired electron. So it is a paramagnetic species. If you do the NMR of this species, then here you can see that the paramagnetic shift. Okay, and you have to do it for the long run scale. Now let's solve the next question. If you have any doubt, please ask me. Anyone having any doubt? No answer, so I am moving then. If you people have no answer question. My next question is, okay, now I'll solve a little bit in spinal questions. Okay, these questions also come in various competitive exams, so I am solving these questions. Spinal you didn't solve, I think, one of the question. Okay, now it's fine. I am giving you a few complexes and we have to find which type of spinal is spinal or inverse spinal. Okay, I'm giving you complexes. Let's find it. Okay. One more thing, I think. Now we'll solve it one by one. Okay. First I'll start with the iron complex. Fe3O4. We can write it here like that: FeO plus Fe2O3. For our simplicity, here the iron is 2, here the iron is 3. So iron 2. And iron 3. Iron 3 is a D5 system and iron 2 is a D6 system. Now, first I am writing it here, then I will explain it. Okay. First I am will solve the what will be the oxidation state, what is the electron splitting, then we'll solve it, then how we can tell whether this is the normal spinal or inverse spinal. MnO. Okay. 3 2. Mn2 is a D5 system. Let me take one page. We'll solve it one by one, no problem. Okay. So another thing was Mn. We can write it like that. The oxidation state, 2 oxidation state. So Mn2 is a D5 system. D3 system. Okay. Now we will solve it one by one. First we will solve it these things, then I am moving to the cobaltone. So D5 systems. So what is the CFEC of the D5 system? Can anyone tell me? D5 system only. 1 2 3 4 5. T2 is here the CFEC is 0. Due to this splitting, it's not getting any stabilization. So it can be anywhere, means it can be in the octahedral field or it can be in the tetrahedral field. So and it's D6 system, means first of all by looking you can solve, but I'm here solving it one step by step. Here the CFEC is 0, but it's having some CFEC. So it always want to be in the octahedral field, as if you keep it in the octahedral field, then it will get stabilization. So there are 2 iron 3. So first of all it will be in the octahedral field, another iron 3 is left, it will be in the octahedral field. and another is left, it will be in the tetrahedral field, because it's not getting any stability in the octahedral field. So why it means it doesn't want to be in the field? So what will be the thing? So this is the inverse final. Okay, here you see D5 system not getting any stabilization. Here it's getting stabilization, so it wants to be in the octahedral field. So it's having 2 Mn3. O4. So what is it? 2 Mn3 are inside. So this is a normal spinal. Now the another question. Here also same thing. It's not getting any stabilization, but it's getting stabilization. So it wants to be in the octahedral field. Mn2. It will be in tetrahedral. O4. Normal spinal. Okay. Hopefully people are getting or with me. Okay, no answer, then I am moving as it's my duty. One, two. Another one was this is a nice question. CO3O4. How we can write it here? CO plus CO2O3. Here we just by seeing we can tell what will be the spinal structure, but here we have to calculate the CFS value separately. 2. This one will be the 3. Oval 2 system. Oval 3. Now we have to calculate the CFS value. T2G 1, 2, 3, 4, 5, 6. Sorry. Now I will calculate the CFS values differently. Oval 2, what will be the thing? 5 electrons in T2G. 0.6 minus 0.4 del O. 5 into 0.6 del O. 2 electrons. So what will be the value? Minus 0.8 del O. In oval 3 case, what will be the value? Sorry, 2, 3, 4 means 4 into minus 0.4 del O plus 2 into 0.6 del O. What will be the value? Minus 0.4 del O. So among 1 or 2, negative sign big quantity means smaller. So 2 will be greater than 1. So it wants to be in the octahedral field. It will get much more stability in the octahedral field than this thing. So there are 2 oval 3. So it wants to occupy in the octahedral side. And oval 2 will be outside, meaning the tetrahedral. So what type of spinal this is? Normal spinal. Okay, hopefully we will get. If you have any question, you please ask me. Okay, no one is responding. I think, okay. Okay, I just want to say all of you that if you have any question, you can ask me in this class, because this is only for you people, for doubt clearing class. So yeah, if you have any question, you can ask me in the comment section of the YouTube channel, or better if you ask me in the NPTEL course section, then we will solve, we'll take the questions, and if you can able to, I able to solve them, then I will solve them and I will let you know. Or if I have some problem, then I will discuss with the corresponding professor, and obviously we will solve it and give it to you. Okay. For today, actually, I took that much questions. Actually, from you people have to bring some questions. Then it will be much more interesting class. So try to bring questions, and I think for today it's fine. And okay, let's meet in the next week. Okay, see you guys.